Another practical use of proportional reasoning is looking at tables. I've got two examples here. In example 1, I have the number of hours that somebody works and the number of dollars that they earn. And just like we did with the proportions, what we want to look for in these tables is to see, are they proportional? Do they represent a proportional relationship? And here's how you can tell. What you want to do is compare your independent and dependent values. In other words, 10, is there a number I can multiply 10 by to get 110? 11. Now let's see, is this relationship true and with other rows in my table also? Because it might not be. It might only be true for one. We have to check it out. Well, it turns out it is true because 20 times 11 is 220 and 30 times 11 is 330. So this table represents a proportional relationship. If I take my values on my left and multiply them by 11, I get the values on my right. That's what makes it proportional. There's a common factor between the independent and the dependent values for every row. So let's use this relationship now to figure out what the remaining rows might be. And all we have to do that is multiply by 11. 40 times 11 is going to be 440. 80 times 11 is going to be 880. Do you want to do the last row? 100 times 11 is going to be 1100. There we go. And there's other relationships you can find within a table that represents a proportional relationship also. Take a look at the numbers and see if you can find other patterns. Hit pause for a minute and then we'll talk about it. Okay, so since this is a proportional relationship, there's some neat relationships that you can see within the rows of the tables too. So for example, I could add these two rows together to get row 3. 110 plus 220 is 330. The same way that 10 plus 20 is 30. So that's one relationship you might spot between the numbers. Do you see any more? You might notice that 20 times 2 is 40 and 220 times 2 is 440. You might notice that 40 times 2 is 80 and 440 times 2 is 880. There's a lot of relationships within the rows of a table when it between the values when we have a proportional relationship. And just remember, the reason for that is because it is proportional. So let's take a look at the next example over here. This one has cups of sugar and cups of water used in a recipe. And it has the middle rows filled out for us, but not the other ones. So what do you notice is the multiplicative relationship between the sugar and the water? Yeah, 1 times 4 is 4. And 2 times 4 is 8. So we have a proportional relationship, and we can multiply the left by 4 to get the numbers on the right. I'm going to pause the video, and why don't you pause the video and figure out what the other values should be now that you know we're multiplying by 4. Okay, those were the two easy ones, right? 4 times 4 is 16. 10 times 4 is 40. Well, what's 1/2 times 4? I bet you know, because you know what half of 4 is. Half of 4 is 2. So 1/2 times 4 is 2. And once again, we have some neat multiplicative relationships between the rows of our table as well. So for example, 1 times 2 is 2, and 4 times 2 is 8. 2 times 2 is 4, and 8 times 2 is 16. If I wanted to go from 1 to 10, I could say 1 times 10 is 10, and 4 times 10 is 40. So we have some neat multiplicative relationships between the rows of our table as well. And you can use those as a strategy to find missing rows as long as you know that your table is proportional, because those relationships will only hold true for a proportional relationship. It won't be true if it's not proportional. All right, so here's one for you to try. Pause the video and see if you can complete this table. All right, so you identified that 2 times 60 is 100. 2 times 60 is 120, and 6 times 60 is 360. So now we need to do 4 times 60 and 8 times 60. 4 times 60 is 240, and 8 times 60 is 480. There we go.